Okay, if you are asked to find the domain of a function, they're basically saying what are all the x's that are allowed to use in that function. So say for instance I have this function, f of x is equal to x, say 2x minus 5. So they're saying what are x's allowed there? Well, there's no real restrictions on what I can put it in for x there. So the domain of that function, you would say something like, it's all the x's as long as x is an element of the real numbers. In other words, anything. If you want to write it in interval notation, you do something like this. You'd say, well, it starts at negative infinity and goes all the way up to positive infinity. So it's basically anything. Similarly, say if you were doing a quadratic function, say you have x squared minus 6x minus 27. Say that was your function, and you're looking to see, well, is there a restriction that I can put in for, or that's in place for x? And there really isn't. So again, this one would be the same thing. It would be, you could put anything. Where you start getting into trouble with domain is if you start having fractions. So if your function looks like this, 1 over, and you have an x in the denominator. If you have an x in the denominator, then one of the rules is thou shalt not, I guess we don't start the rule with that, but anyway, you can't have a 0 in the denominator of a fraction. So if I just have 1 over x, I can say, well, plug in any x you want, but in this case, x cannot be equal to 0, because that breaks the rule of thou shalt not have a 0 on the bottom. If you want to write that in interval notation, you do something like this. You'd say, well, from negative infinity all the way up to 0, not including 0, and from 0, not including 0, to positive infinity, the union of those two things, that is your domain. Those are the allowable x's. Now you can see this kind of question in lots of different cases, because they might do something like this, x minus 2. Then you have to ask yourself, well, what can I put in for x that'll make the bottom 0? And if I can do something like that, then that number cannot be part of the domain. So in this case, hopefully you can see that if I put a positive 2 there, 1 over 2 minus 2 is 0, can't have a 0 on the bottom. So you'd say, you plug in any x you want as long as it's not a positive 2. Or you could do similar to this one, say from negative infinity up to 2, not including 2, and from 2 all the way to positive infinity, the union of those two intervals, those are allowable numbers, or that's the domain. They can also do one like this, where they'd say 1 over, maybe I'll do that one, x squared minus 6x minus 27. So they say, what's the domain? Well, that one's a little harder to identify what values of x. So what you could do is factor that. Maybe I'll go down. So if I factor that, it'd be x minus 9, x plus 3, I think. So in this case, I look here and I say, well, I could not put in a positive 9 there, nor could I put in a negative 3. So you could say, plug in any x you want, as long as it's not a positive 9 and it's not a negative 3. Everything else is fine, just not those two numbers. Interval notation, you do the same thing. Negative infinity up to negative 3. And, whoops, and from negative 3 to 9, and from 9 to positive infinity, the union of those three intervals, that would be your domain. In other words, like if I had a number line, you could say, well, here's 0, here's negative 3, and here's positive 9. So all your x's would work up into negative 3, but they'd stop there. And then from negative 3 up to positive 9, those ones are good too. And anything from positive 9 up to infinity is good. Hopefully that gives you an idea of what they mean or what they are asking when they say, what is the domain of a function? Well, maybe the other thing I could say too, sorry, you can have square roots too. So if you have a square root of a number under the real numbers, you can't have a negative number under there. So if I say had an x here, you would say, well, x, you can plug in any x that you want as long as x is greater than or equal to 0. You can take the square root of 0. But if you try putting a negative 1 under there, it's a complex number, and typically, well, not typically, under the real numbers, we say that's not possible. So if you had a function that says square root of x minus 7, you got to figure out what numbers can I not put in there. So 7 I could put in, because 7 take away 7 is 0, and square root of 0 is still 0. But I couldn't put a 6 in. 6 take away 7 is a negative 1, can't take the square root of negative 1. So anything, I guess, from 7, not including 7, and lower. So you could say the domain is make sure all the x's, as long as x is greater than or equal to 7. Now, if that's sort of hard to figure, what you can do is just take that and say, well, x minus 7 has to be greater than or equal to 0. And then solve that inequality. Add 7 to both sides, and you get x is greater than or equal to positive 7. In interval notation, you'd say 7 is as small as it goes, and I can include 7, so I put a square bracket, and I can go all the way up for forever. Okay, hopefully that'll help you.